Hey everybody, happy Tuesday. Alright, we have got all sorts of fun on tap for today. Oh, I don't need my chess game open. I can close that now. Alright, so we are moving on now, hopefully with better internet. Things I think are much more stable than they were before. Let me know if that's not the case. But after the router reboot and then Comcast fixing whatever issue they had on their side, the rest of the classes went reasonably well. And now I'm realizing I feel bad because I had said, hey, you guys should watch the Thursday night video. But that's like 2 hours of watching stuff that's not your Thursday 10 to noon class, and I'm feeling bad about that. So I'm curious, did you guys actually get a chance to watch it? Like, yes, no? Because I can talk more about Project 1 that was assigned, in case you didn't get a chance. Okay, so that's good. I'm going to try and not do that in the future, because that's, like, if I don't have the material ready at your time slot, that's unfortunate. Because I know you guys are busy people, and you have other things going on in life. Okay. No, no, I appreciate that. That's all fine, Mindful. So Project 1, the idea was to have it due a week from Thursday at 6 p.m. So the problem is, you guys both get the same assignments. I think that's actually a good thing, because that way you can attend either class. But now, I think it's working out well. But I'm going to go over the solution 6 p.m. on February 4th with the Thursday night class, and I'll cover it the next Tuesday morning with you guys on, let me pull up my calendar here. Look at that. I know what dates are. So then we would go over it in class on the 9th, but I have to have it in by the 4th because I'm going to go over the solution Thursday night with the Thursday night folks. So I've got to have it in and committed and everything ready to go. So we still get another week and a couple days on that, week and 2 days before it's due. You fine folks? We've got a couple study sessions in between then. And we've got Chapter 8 that we're going to be working on. But I think this sort of schedule should work out well. And then, as long as you get it in, yeah, I think this should be fine. All right, so why don't we talk about it? So we have done some examples of writing classes and writing unit tests. And that's what this is what our first project is doing. We're writing a class and we're writing some unit tests to make sure that what we expect to have happen does happen. And that's the whole goal. That's the whole reason we write unit tests, because we got to put into code and make the computer check our expectations. Because remember, the hard part about software engineering and programming is solving the problem. Breaking down a big problem, putting it into smaller and smaller and smaller and smaller pieces, and figuring out what tiny steps we can make a computer do to solve the problem. So if I can break it down into those steps, then I can say, okay, well, if I know these are the rules and this is what's supposed to happen, let me try it and see, did I get what I expected to have happen? Did that actually happen? And that's all we're doing with our unit tests. Man, this mug is a large mug, but it empties fast. That's unfortunate. Come on, NetBeans, wake up. It's upset about something. I think I'm okay. Yes, no problem. No problem. Happy to talk through these. So it's very similar to the example we did with vehicle. What's setup? Like my computer? Is that what you mean, Whisper? Or Wispy? It's a Surface Book 2. So it's got a decent graphics card in it. And decent set of hardware, but it's just coming on 2 years old now, unfortunately. So it's not as snappy as it used to be. I'm probably due for a reload. That's the next part here. project. I want to open up the previous project. Here we go. So let's take a peek at the vehicle project that we tried to get going. The quiz, I didn't get it posted till Thursday night, so I just pushed it out the due date till Friday for you guys. So I said, if you can get it in by Friday, we're in good shape. Where's our class here? Here we go. Here's our... Hey, thanks for coming by. All right, so I think this was vehicle, right? Nope, that's the wrong project. Here we go. Yeah, so make sure the quiz is coming up Friday by 11:59 p.m. And then if you had attended study group in the week when we were working on that material, either the first or second week, right? Because we're in week 3 now. Yeah. Yeah, so if you had attended study group one of these 2 weeks, you'll get a bonus point on the quiz. I just need to coordinate getting those attendance sheets and things with our awesome SI. Then if you can attend study group during this session, one of the sessions during this week, you can get a bonus point on the Chapter 8 quiz when it comes to that. Well, you can come to the one this week then, Snake. But yeah, so it'll make it possible to get 11 out of 10 on the quiz. So hopefully that's a nice incentive for you guys to come. And I mean, I was just excited. The data shows like students do better if they can attend SI sessions. So. All right, so what we did with vehicle is we had some information about vehicle, like its make, its model, its color. I added color for fun, I guess. And then some other information like its gas tank capacity in gallons, its miles per gallon average. And yes, I know this does change in real life, depending on the weather, depending on your tire pressure, depending on highway driving, city driving, that sort of thing. That's probably more complex than we care about, right? We're not actually in the real world here. We're just doing an exercise that is going to get us close. And then in actual gas in the tank, and this probably should have mentioned in gallons. Yeah, it's an average, sure. So it's not precise. We're not going to use this for a self-driving car, don't worry. And then we wrote a constructor that accepts most of these values. Remember, the constructor's job is to give all of our instance attributes values. So the constructor's job is to set them to something or accept them as an argument. So in our case, you tell me what the make, model, and color are. You tell me your capacity and your miles per gallon average. Then we said, oh, you start off with no gas in the tank. So because that is an instance attribute, our constructor needs to give it a default value. So we're just going to start you off at no gas, right? And then we had a set color method that we wrote because we wanted people to be able to change the color of their car. Remember, we get to decide what sort of access people have. We make these values private because we're encapsulating all of our details away and only giving them that abstract interface to work with, just our public methods. So once you have a vehicle with a make and a model, that doesn't change. Right? You can do all the fiddling with it that you want. It's still the make and the model. Right? You can make it look different, sure, but it's, it was still made by a company and it still started off with that model. So those ones we're not going to give you set access to. So there's no set make, there's no set model. You create it once in the constructor, and you notice they're set tagged as final here. That final attribute means it gets set one time, and then you cannot change it in code. So it gives you some additional code level protections to make sure you don't change these things. Again, the gas tank capacity, I guess that one could change if you really wanted to take out your gas tank and put a new one in, but I doubt there's room for that in most cars. Again, I actually don't know very much about cars at all, but I'm assuming that's probably the case, that you can't change the size of that very easily. Okay, but your miles per gallon average, sure, we'd let it be changeable, but maybe down the road we might change it here or have some sort of adjustment. But so I didn't mark that one as final. And then the actual gas in the tank, as we drive, we're going to go down in gas, right? Because we're using the gas, and as we put gas in the tank, we're going to go up. So obviously this one we want to be changeable. So, but like for color, we had a set color method. So if you want to change the color of the car, you have access via a public method to go give me a new color. So currently my Chevy Bolt is gray or silver or whatever they wanted to call it. If I wanted to go paint it, like my daughter wants me to do, and go make it blue, I would go take it to a paint shop, and with our class here we would call set color and change the color to blue. right? We need ways to interact with the objects. So that's what the public methods. The rest of these, the get methods, get model, get make, get color, get gas tank, get actual, and get average. Like, these are boring gets. And remember, I think we got to where I showed you how to generate these. Does that ring any bells? So I'm actually going to delete them for a second here, and I'll show you this amazing trick. So I right click and it's under insert code, or you can go to the source, I think it's source, oops. Insert code, right? Or alt insert if you like keyboard shortcuts. And we want to insert, come on, NetBeans. Insert code, there it goes. I'm going to insert getters. Those are the get methods. Yep. We want to be able to get all these values. We say generate, and again, it puts them like wherever you inserted, wherever your cursor was. So I'm going to move those just because that offends me. Typically, I put the attributes at the top, and then the constructor, and then all the methods. So I'm just going to paste them all down here at the bottom. So those are the gets. Okay, set color, sure, it was great. And then the tricky part now is we had two ways of interacting with the car. We could add gas, and we could drive. So we don't have a set gas, because I don't want you to directly change the amount of gas in the tank. I want you to use add gas, so we can add some gas. And we do some sanity checking here. So the idea is, okay, making sure it's a positive number. So you don't try and do weird things. So people do the weirdest things to our code. And if you try and add a negative amount of gas, and we didn't do any checking here, we would have taken gas out of the tank. Yeah, I mean, for all of our stuff, we just throw it all in a single package right now. Doing larger bits of code, Wisp, sorry. Larger projects have their own sets of organization and how you ever want to tackle them. We're not going to get anything that large where it's going to matter much. So we just have separate packages for the code and for the test. So we're sanity checking, right? The idea behind our class is that we should protect the integrity of our values. Right? If we're writing the class here, we're in charge of the logic. We need to make sure that we don't get into a bad state. That's our job. Right? The class should not let its public methods be abused and put itself in a bad state. And we haven't talked about exceptions, so we don't know what that is yet. Don't worry about that. So we said this is a Boolean method. It will return a true or false. So if you try and give me a negative value, I'm going to return false. And just, hey, adding gas didn't work, something bad happened. Maybe an exception is better, but again, we'll get to that later on in chapters. So we're saying, okay, if it's positive, great. Let's go add gas. Hey, no worry code, no worries. So we're going to change our instance value, the gas in the tank for this instance, to whatever you told me. And then I'm going to go check. Hey, did we overfill the tank? Yeah, that's all right. You can always catch the first 30 minutes after. No problem. Although we're only 15 minutes in code, so I don't know if you need a new watch. I'm just teasing you. I'm sorry. So if we went over our capacity, we're going to just pretend like we didn't spill any gas, because, again, this is just pretend. And then we're going to say, hey, let's set our actual to the capacity. And then we're going to give you back a false because you screwed something up. Like, it didn't work like you expected. If that didn't happen here, we're going to return true. Sure, we added the gas, nothing bad happened, return true, and that's our indication that this was successful. Another thing we talked about is a lot of people like to do this thing, and they'll put print lines in their code. Note it's redlining because it comes after a return. You can never get here. But again, don't put print lines in your classes. This is a big no-no. Remember, the idea behind writing a class is that this code is so awesome and amazing, and I can use it in multiple places, right? This idea that my code is portable. It might be a console application now, but maybe it will be a web application later, or maybe a mobile application, or maybe just running on a server somewhere, just some server software. No one is actually sitting there looking at it running. So if you print a message to the console, no one's going to see it. I mean, in this case, we know, yes, we're sitting at the console, but that's breaking this idea that a class should do just class things. So printing errors is a big no-no inside the class. Okay? Again, that's what exceptions are for, but we haven't talked about exceptions, which makes me sad, and that's okay. So probably never use console prints or reads with scanner inside of a class. Right? The class's job is to do class things. If you need console input and output, you do that from your main method or whatever portion of your program is running here. Okay? That's another design thing here. And that was add gas. And a similar thing with drive. We're going to check, hey, how much gas do we need? So given how many miles you want to drive, you want to drive 100 miles, let's figure out what our miles per gallon average is. So if we get 25 miles a gallon, we'll need 4 gallons of gas. If it's more than we actually have in the tank, we just return false right away. We stop. So we're just not even driving at all, rather than driving till we run out of gas and then stopping. Sure, that's how we designed it. That's what we wanted to do. If we didn't return false, we'll take the gas out of the tank and then return true. This thing worked. So those are our ways of interacting with the vehicle. Right? We can add gas to it and we can drive. It's not a set gas or set actual gas in tank method, because I wanted to go through this logic. We said, hey, this is what the class is supposed to do. This is the business logic I need. Once we understand what it was supposed to do, right, we could go and write tests for it. So again, what you previously probably would have done is try and go add some things. So I made myself my Blue Jean, my Ford Transit, the kid's named Blue Jean. It is Blue Jean Metallic, right? So the make, the model, the color. So I told the kids what the color it was, and they're like, oh, it's a Blue Jean. So we've called it the Blue Jean ever since. So sometimes you get funny names with kids. It gets about 25 gallons of gas in the tank, somewhere about that for the capacity, and it gets about 14 miles a gallon on average. Again, depending on highway versus city, and we're just picking a number here. So all of the input and output happens here in main, or whatever functions, methods I want to write inside this part of the class. My vehicle, I can call add gas, right? So this is the sort of stuff you would have done for testing previously. Like, okay, how much gas do we want to add? And get some input from the keyboard here. Again, I'm always going to recommend you use next line with scanner. Don't use the next int, next double stuff, because then you get those hanging new lines, and that's a big pain. So always just parse it. Parse a string, and you'll be better off. So we try and add that amount of gas, and we're checking, because this returns a Boolean. Remember the add gas method that we wrote. When we add gas, it either returns false, or returns true, or false again, right? So we're either going to get a true or false back. So I put that right inside an if statement. If I get back a true, great, you added some gas, don't forget to pay. If we get back a false, because I put too much gas in, or a negative value, something went wrong. So all my error messages and things are happening here where I have console input and output, because I know they're running this as main, and I know we're getting console input already. So all of the checking happens on this part of the program, not inside of the vehicle class. We're not doing any input-output here. All the values vehicle needs come through methods. You tell me the gallons here. So we're trying to separate those pieces here. So just the vehicle class just does just vehicle things. Right? All the input-output happens in the main, where we have input and output. Oh, we also talked about how Java is bad at math. That was fun. Okay, so hopefully this is familiar, right? We would write a class and we would do something with it. I've heard from more than one student now that this is not familiar, and that made me a little bit sad, and wonder what happened in your 1500 classes if you didn't write a class. But that's okay. We will persevere, and hopefully this week of review was good, and we're just going to keep going. And I don't think you'll be too far. Oh, dad joke. You got it, Code. I was actually just looking for some good ones last night. No, I don't want to update my phone. Not in the middle of the day. Let's see. So yeah, so if this was new, that's okay. You guys will be okay. We can catch up, but this was the gist of it, and that's why we do some review time. Here we go. This one's for you, Code. So I was going to start a new club, like for Apathy Anonymous, but I thought, why bother? Man, that was a pretty good one, right? All right, I got one more. Um, you know those the spray deodorants that became really popular that have those nice strong smells. Um, I accidentally sprayed some in my mouth, and now I've got this really weird accent. Posture check. Thank you. Yes, let me get out my board here. It certainly was a joke. Yeah, you could say that. Okay, you like the axe joke better? Okay, better than apathy? Save it up for the word ban. Those ones are tricky. Those are definitely tricky depending on what word you ban. I will do my best. All right, so we have our class. So instead of having to do everything here and give it some values and run it and look for outputs, what we're doing is we're making the computer do all the checks for us with unit testing. Let me just go change the price of that right now, Scholar. Change the bytes. So the idea with a unit test is we know what the class is supposed to do, so we're going to test it. We're going to give it the value and see what we get back out. And a unit test typically focuses on one small unit, one small chunk at a time. So we're going to test the add gas method here. And we're going to do this with this AAA formula. We're going to arrange, we're going to act, and we're going to assert. So we're going to set up all the values we need for testing. So I expect to have 4.2 gallons of gas in the tank. Okay? So I'm going to call my code. I'm going to make a vehicle. The values here don't matter. Make, model, color, we don't care. As long as I have more than 4.2 capacity, I'll be okay. So that one's important here. And then miles per gallon average, we don't care. So most of the values we don't care about. And then we're going to get the add gas result. So we'll make the vehicle, and then we'll call add gas, given the expected gas. So I'm going to try and add 4.2 gallons. I'm going to save my Boolean result. Okay? And then I'm going to ask the vehicle, hey, how much gas do you have in the tank? This is getting the actual value back out from our code. And then we're going to assert, did we get what we expected? So I expected to have 4.2 gallons in the tank. I actually have, well, let's see, it should be 4.2 if we did it right. And then anytime you're working with doubles, when you use this assert equals, you have to give it this delta. And the delta says, are you close enough? Are you within this range of each other? Because remember, Java is bad at math, and you get some really weird trailing nines or zeros or 0.00001 stuff. So you said, okay, my expected should be the actual, and then I'm also going to assert that I should have gotten back a true. So you can have more than one assert here. So we did both, because I should have gotten true, it should have worked, and then I should have that much gas in the tank. So we set that one up so we can run it. We should get a green check mark. Thinking about it. I think my computer wants some coffee too. There we go. And so it passed. So I didn't get any fails. That's good. All right, and then I'm also going to test. So the idea with testing here, so add gas, we know we got to this return true, because we got a true back. What we don't know yet is if this part works here, because I haven't tested, hey, did I add more than I have capacity? I haven't tested that. So there's a term called code coverage when it comes to unit tests, or really any testing, specifically around unit tests, so how we're going to use it. The idea of code coverage is how many lines of code actually ran while your test was running. And they've got some fancy tools, and I think most of them you have to pay for to measure that sort of thing. But I know that these 2 lines of code never ran in that previous test. So my code coverage here is not at 100% of my code was actually running. Right? This line ran, and this line ran. So I've gotten 2 out of the 5 here. Right? So for this method, I only had 2 out of 5 lines of code running. I mean, I guess that's also a line of code. It's not a statement or a command, but so anyway, the idea is we want to exercise all of the code, because any code that's worth writing is worth testing. Right? We want to make sure it does what we expected it to do. This is our sanity check. So I'm going to write another test. Now, some people throw them all in one. That's bad form. Right? A proper unit test should be small and concise and test basically one thing. Again, there's slight variations to that rule, but it's really easy. Now I'm just going to add another method for test add gas over capacity. I'm going to say I expect to have 2 gallons in the tank. If my capacity here, my max capacity is 2, and I try and add 4.2, I should get back a false result that it didn't work. And then my expected gas in tank should be 2, because I tried to add 4.2. We're just going to pretend the extras went away. We didn't pollute anything, thankfully. And we ended up with 2 gallons of gas. That's what our code does. If you try and put in more than we had, we just pretend like we stopped. And again, you get back a false. So it's checking both things. Did we get a false because something didn't go right? And did we stop at the capacity here? Did we stop at 2? So far in vehicle now, I've tested this line. I've tested this if block. I've tested here. I haven't tested this one yet. So I'm going to write one more test. It gets a little tedious, but anything that's worth writing is worth testing. You want to make sure you did it right. So I'm going to test giving it a negative value. Here, so I write another test. And again, the names here, the idea is you want a nice, meaningful name, so that if it fails, you know what test failed without having to go look. Some people say test add gas 1, test add gas 2, test add gas 3. That's terrible. You should feel bad about yourself, because those are meaningless names, and you have no idea what it failed. And then you have to go look it up. So sure. So I'm going to say, okay, I expect to have 0 gallons of gas in the tank, because I'm going to make a vehicle and try and add negative. That means nothing should change, and I should get back a false. So I'm going to say, did I get a false result? And do I still have 0 gallons of gas in the tank? Oh, excuse me. Sorry. All right. So assert equals is saying the expected value matches the actual value. Assert false is just saying, is this thing false? Hydration, thank you, Wispy. Is it Wispy? I apologize. I do try and get names if I can. Okay, so a third test now. Okay. Will 1 sp 3? Is that even better? Will 1 sp 3? Wisp the third. Oh, that's right. Yeah. Wisp the third. I forget all these things. You guys got to remind me. But I do appreciate you chatting here. I get bored talking to myself or hearing my own voice out loud. Especially the night classes, like going 4 hours of me talking. Oh, nobody wants that. So it's always good to take breaks and have some conversations and questions and whatnot. Ah, you wanted whisper. 4 hours of me talking would be awful, sweet tea. Sure would. Just wait till data structures this summer. That will be fun. That will be fun. I'm excited. Yeah, no, keep the questions coming. That's great, Mindful. Questions are good. Talking to yourself. Yeah, and you get used to it a little bit, but it's nice to have some feedback. Okay, so with the 3 different unit tests, I've now tested 100% of this add gas method. Okay, yeah, I can help with your NetBeans after, sweet tea. Excuse me. You can do all sorts of fun math stuff in Java, for sure. Yeah, calculus and linear algebra, they're good things, but depending on what field of software engineering or programming you get into, you need the math, you don't. It just kind of depends what specifically you're developing for. It just depends what you're developing for. All right, so I've got 100% code coverage because every line of code runs during my test. But unfortunately, that doesn't guarantee that I'm bug-free. Right? It's still possible, but despite me looking at the code, writing tests for the code, it's still possible I screwed something up. It's harder now because I'm checking to make sure it does what I expect it to do, but there's no guarantee. Right? So don't feel like just because we wrote unit tests got 100% code coverage means it's perfect. You're much more likely to be correct, but there's no guarantee. I have done the wrong thing in code and then tested the wrong thing before, where I designed it badly. I didn't actually solve the problem correctly. And I was testing that I didn't solve it correctly because I thought that was the correct solution. So that sort of stuff can happen. So don't feel bad. Okay? So that was testing for adding gas. Now we're going to test drive. Now drive, again, had two different cases. Either we didn't have enough gas, or we did have enough gas. And we did drive. So in this case, we didn't go to run out of gas. We didn't take all the gas away. We just said, hey, if you want to drive 500 miles and you don't have the gas, don't start. Because we could probably plan that ahead. That sort of thing. Okay, so the first test drive then says I expect to have 4 gallons in the tank. I'm going to add a capacity of 5. I'm going to add 5 gallons, and I have 10 miles per gallon average. So if I drive 10 miles, that should be true. It should work. And then I should be at 4 gallons of gas left over when I'm done. So again, we're arranging. These are the variables I need. I'm going to call the code. Now, some people might actually put these two lines up in a range. I'm not too particular because drive is specifically what we're testing. So sure, if you want to move them up into a range, that's fine. I don't, not too particular. But does that make sense? How we're saying, hey, if I give you 5 gallons of gas, and again, I have to use these public methods. I have to call add gas first. I'm not testing add gas here. I've already tested add gas. I'm testing the drive portion here. So maybe it makes more sense to put this up here. Because we're just doing this thing, but again, I don't know. I'll just leave it. So did it drive, true or false? And then how much gas is left in the tank? The get actual gas in tank. And then we're going to try the other case where we're trying to drive too far. So if I try and drive 100 miles, so I added 5, right? I guess I could have just added no gas, but sure. I guess that was kind of meaningless. Didn't have to add any. Well, this was good. This is making sure it doesn't change, I guess. So we add 5 gallons and make sure we still have 5 gallons because we didn't even try and drive. And we get back a false result. If I try and drive 100 miles, if I get 10 miles a gallon, I would need 10 gallons of gas to get that far. And I don't have 10 gallons of gas. So our code says, nope, you just return false. We don't actually use any gas. We assert false. And then set color. This one's boring. We just give it a color. Sure, did we get the color back out? Get make, this one's boring. Get model, that one's boring. Again, getting gas tank capacity in gallons is boring. Getting miles per gallon average is boring. Did I hand it to the constructor and did I get it back out? Assert equals. That is the delta to make sure that the numbers are close enough. Because if we go back to here, remember with Java, if you subtract, what is this, some thousandths here a bunch of times, 100 times from a number, let me run this one. No, this was the example to illustrate what you'll be doing for the first project. The first project is a different class and different tests, obviously, because it's a different class. So I subtracted 0.000001 100 times, but I've got this 0.83 over here. Java's bad at this. I mean, to be fair, most programming languages are bad at doing double arithmetic with all these decimal places. But this has no business here. So what that delta does is it says, hey, if you are within this of each other, right? So absolute value, one minus the other. If it's less than that, you're good. Does that bring back some memories from math class? So it gives you that little fudge factor to say, oh, okay, if you've got a little bit of rounding error over here because Java sucks at math, just ignore it. We're okay. We're still equals enough. We're almost equal at that point. And it won't let you, if you're comparing doubles, it won't let you run it without that. It'll give you this, hey, this is bad. You need to use the delta. Sorry, I should put my phone on quiet. Ay, 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 ay. Sugar is just nuts today. All right. Yes, the assignment is about a plane. Yeah, pretty much what decimal place it cares about. Is it within this of each other? Yeah, exclam class there, Magic, if you want a little more info here. What's going on today? So that's what we did with vehicle and vehicle test. All of that now to come look at project 1. Now it's your turn. Magic Gnome Gaming. That is awesome. What a cool handle. So we're going to be writing the plane logic for an autopilot program. Let's just pretend to make you feel like we're doing something meaningful. We're just, sure. So we're going to write plane. It's going to have private attributes for max altitude in feet, landing gear enabled, which is a Boolean. It's either true or false. The model of plane, which is a string, and current altitude in feet. Okay? So those are our private attributes. We're going to add get methods for each attribute. We're going to write a constructor that accepts model and max altitude, and then gives good starting values to the others, the landing gear and the current altitude. So like once you make a plane, if it's a 747, it's staying a 747. And a 747 will have some max altitude. I forget, they cruise at like 50,000 feet or something ridiculous, right? But different planes have different max altitudes, right? Not all planes go quite as high. That sort of thing. We write the constructor. Yeah, so our constructor here for vehicle took make, model, color, gas tank capacity in gallons, and miles per gallon average. This was the constructor. It set those and then gave a good default to actual gas in the tank. Yeah, Magic, you're getting into actual details that we're just not going to pretend. We're just doing an exercise here. So we'll pretend landing gear turns on and off instantly, because it's just code. We're just pretending. Okay, so this is our constructor for vehicles. We're doing a similar one for plane. Nope, this one here. Okay, then we're going to write some interesting methods. Sure. We're going to have enable landing gear and disable landing gear. So they both function differently, right? One will turn on the landing gear and one will turn off the landing gear. But some business logic here. If our current altitude is more than 1,000 feet, don't enable the landing gear. We're probably too high up, going too fast. Bad things will happen. Again, I'm just making it up. It's probably close to real life, but totally made up value, right? I'm not an actual pilot. My father has a private pilot's license. It was really fun. I used to fly in Cessnas with him as a kid. So we're just going to say, hey, if you try and enable landing gear and we're more than 1,000 feet in the air, don't do it. Just like we had done in our vehicle, if you try and drive too far, don't do it. Right? Just don't. Right? The class itself needs to protect its integrity. If you're at above 1,000 feet, don't let the landing gear turn on. Right? This is that autopilot feature. Exactly. Just don't. It's the opposite of Nike. Just don't do it. Right? If the current altitude is less than 1,000 feet, don't let someone disable the landing gear. Right? If we're below 1,000 feet, don't let them put the landing gear away. So for enable, right, above 1,000 feet, don't enable. For disable, if you're less than 1,000, don't disable. Just don't it. I love it. And don't do any text outputting from the plane class, right? Don't print error messages there. Just don't change the value. If you want to return true and false, great. I'm not going to make you do it on this project. Like, I'll show you how to do it once, but I'm assuming you guys can handle that if you wanted to. Okay? That's the landing gear, enable and disable. If you want to do it all in one method, you could, and you can accept a Boolean with like true or false for enable or disable, but that seems more complex. I think this is just a little simpler to have two different methods. Yeah, you can throw exceptions, Big E. That's right, you had me last semester, didn't you? So you probably know what an exception is. That's cool. There's no points for it in the rubric. I mean, I think it's easier to have two different methods here, Vivanzo. So if you want to do it in one, that's fine too. Oh, okay. Yep. Cool. Then we're going to do change altitude. Now this one needs to be a little smarter because we're going to accept positive or negative for this one. So we're not going to have plane go up and plane go down. We're just going to have a single method for change altitude. If you give it a positive number, it goes up. Give it a negative number, it goes down. Okay, a couple things about that now. Don't let it go above the max altitude. Just like when we were adding gas, we did not go above the max, right? Just don't do it. Sure, let them get up to the max, just like you got up to the gas tank capacity, but you can't go over that. And then when you're going down, don't go below 1,000 feet if the landing gear is enabled. It's a college class, micro or magic. I think XClam class will give you a little bit more info. Snake. So if you were trying to change our altitude and go negative, don't go below 1,000 feet till landing gear isn't enabled. So the 1,000 feet needs to stop, right? So if we're trying to go negative, stop at 1,000 and don't go any lower. So that's like, hey, we have to pause here and enable the landing gear before we can go further down. Yeah, I mean, they've got programming classes in high school as well, and like AP Computer Science sort of stuff. You can, I think they typically teach that in Java. But weirdly, to teach at the high school level, you need to go get a teaching degree to learn how to teach. And then you get a specialty in like the field you're going to teach. To teach at the college level, you need to go get a master's degree in the field you're going to teach in. But you don't learn how to teach. So, you know, it's kind of fun to learn as you're going. Yeah, actually, my school didn't have a AP Computer Science, but they were able to dual enroll me, and I was able to, I actually went to OCC, took the earlier class as a senior in high school. It was cool. So that's what change altitude does. That's our enable, disable landing gear. So we have some logic here that happens, and then we're going to write code tests to ensure 100% code coverage. That makes sure every if-else block, every line of code will run. So just like when we were doing our add gas, we made sure that this one ran, and this one ran, and this one ran. So maybe it takes 3 tests. Maybe it takes 4 tests, right? Whatever it's going to take, right, to make sure we get 100% code coverage. So we're not going to officially measure it with a tool. We're going to have to just eyeball it. Okay, and that's project 1. So there's a rubric here for project 1. 10 points. You get a point if your plane class has all of the attributes and they're private. You get a point if all of your attributes have public get methods. Ooh, robotics programming is really cool. You get a point if your constructor accepts arguments for max altitude and model and sets values for all the other attributes. You get a point for enable and disable landing gear methods. And you get a point for change altitude. Okay, so that is 5 points for the plane class doing the things it's supposed to do. Then, is that first robotics? Oh yeah, the first stuff is really cool. They do some awesome stuff. Yeah, if you, I mean, I don't think you're copy pasting anything from here. It's all different. So I'm assuming you're gonna kind of use this as a reference, but there's no copy paste. So the citation would be like, hey, this was a reference for me, and I'm assuming my stuff is referenced, right? If you copy paste it, yes, please leave a citation. You can leave a link to the URL, but if you're just referencing my stuff, I'm assuming that's what you did. Okay, so you don't need to cite that. Right, so we get 5 points for the plane class, and then we get 5 points for the unit tests. We're going to unit test the plane constructor and make sure we get the values back out, right? So if we create an instance of plane, we get stuff back out, right? If you test the enable landing gear, you get 1 point. If you test the disable landing gear, you get 1 point. Again, if it's all the same method, that's fine, as long as enable and disable happens, right? And then 2 points here for testing your change altitude, because that one is a little bit more complex. Ooh, Python's a lot of fun. I like Python. So half your points for the class, half your points for the unit tests. That's project 1. Questions, thoughts, concerns about this one? I'll pause for a minute. Let me throw out a Twitch poll here. and see how you guys are feeling about project 1. So let's see, project 1. So pick an option here that comes up in a second. So a couple options. You have no idea what to do. You need to try it first. You feel good about it, or you're already done with it. So in Twitch chat there should be an option. And take a look there. Yeah, so assert equals, if you have a Boolean, is kind of redundant. So I don't want to say assert equals, does false equal false, when I can just say assert false. So this is just shorthand. It'd be the exact same thing as assert equals. I would like expect a false. Nope, sorry, expect false and my add gas result. So this is the exact same thing. We're just saying, hey, it should be false rather than does false equal false. Yeah, hopefully if you had me for 1500, you're in more prepared for this than if you didn't. So it should be at the top of Twitch chat. Oh, if you're on the phone, I'm sorry. Let's see. I have to view the results. Funny, like it doesn't just show it for me. Okay, 9 people feel good. 5 people want to try it first. 1 person's already done. All right, good job. Okay. Oh yeah, if you're on the phone, you can just shout it out in chat too if you want. If you're on a phone, can you even read the code that I'm typing? I'm feeling bad now. If you guys are on phones, so I've tried to zoom in a little bit, but that font has got to be small. Okay, cool. So I'm glad you guys are feeling good. Should be in good shape here. Someone asked what compiler. This is Apache NetBeans we're using. Okay, yeah, and I can just change the font size too. It does zoom in and out, not zoom, but I can like change the font size. Wish it had zoom, but that's okay. Yeah, this is Apache NetBeans. Okay. Yeah, there's lots of good compilers. All right, so this one again due February 4th, 6 p.m. And I can't take this one late. Right, Project 0, I was able to be a little bit flexible, but this one, if it's in late, I've already gone over a solution, and I can't take it. Okay, so get started early, and again, what you're turning into me is the URL to your code in your GitHub repository, just like you did for Project 0. So let me pull mine up here, and I'll show you. Right, you'll go find your code on github.com. And you can go into your folder for it, probably named Project 1, because you guys name things well. And you can just give me the link, because you're going to have test code there too. If you just give me the link here to the folder, I'll be cool. It should be in my bio there. JGrasp. JGrasp is okay, but it doesn't have all these good testing features last time I checked. Thanks, chat. Yep. So just give me this link here, like to the folder, and I can go look at your source code and your test code for what you're going to turn into Desire to Learn. I think I set that up right, that you submit a URL. Let me check. Sometimes I'm bad at D2L. Oh yeah, VS Code is pretty good. I haven't done anything with it in Java before, but apparently the plugins are decent. Submission. Oh, yep, not file. We want text submission. There we go. Please, let me add that. So please submit URL to your project directory, github.com. All right. Once someone submits something, I can't change that, which is really obnoxious. So let me actually go change that here for the other class before I forget. Look at that. Make this work. Ooh, I gotta grade some of their stuff. All right. Oh, someone submitted. They probably submitted the file. Shoot. All right. That's fine. That's fine. My mistake. So unfortunately, you have to be registered for the course to be in our course management tool there, Magic Gnome. And that's the only way you can get grades and things. All right. So why don't we take a break? We're coming up on 11 o'clock here, getting close. I'm going to go get some more coffee because my cup is empty. And then we'll pick up some new stuff and start into Chapter 8, our second look at classes. Sound good? All right. Put some music back on for you guys. Maybe hit play. In a cup and on PC. Yes, Snake. Java is good both ways, for sure. Oh, this one's like fading out now. Okay. I had like 3 more bars there. All right. And we'll come back, not 11:07. How about 11:05? Or 03. 11:03. Maybe about 10 minutes. All right. I'll see you guys in a little bit. Alrighty, gang. Let's see if I can fade this out nicely, right? That was too fast. The volume here's tricky. Oh, you guys can't see anything yet. Here we go. Switch the scene. Alright. We're back. We're back. Alright. Oh, I should just pause the music then, right? Just close that. We're probably good for now. Alright, so we're going to move on then. We talked about Project 1. We're going to move into Chapter 8. Remember, Chapter 7 was the Java arrays array list. We did that back the first week. We'll do more with them, and we'll get into some two-dimensional arrays. I mentioned them, but I didn't actually, we didn't do a whole lot with them. So we'll come back to that at another time. Don't worry too much about it. Oh, we got an espresso. All right. Yeah, espresso's good stuff. Funny, at Starbucks, when you get a free drink, you can like add as many espresso shots as you want, which is really fun. Oh, pasta with a fried egg. That's good stuff. Yeah, no, I used to be in a Red Bull, but now I'm diabetic, and the sugar in Red Bull just kills me. So, no, you can add all sorts of shots. So, but you know, save up for the free drink reward, because otherwise you pay for every shot. All right. So our second look at classes and objects. We're going to spend the next week and a half here in Chapter 8 going over this stuff. And we got a lot of additional stuff about classes that we're going to get into. And then we'll start talking about Project 2 on February 4th here. So I'll give you the assignment on February 4th, so you can start it if you want. I know Project 1 isn't due till 6 p.m., but that way, about every 2 weeks we'll have a project. That's sort of the planned flow for this. So project, and then the final project we'll have a month for. And again, if you do want to plan ahead, get to know your fellow classmates. You can use Desire to Learn if you actually want to know people's names and things. Don't use people's names and stuff in Discord and whatnot. But the final project you guys can pair up if you want to. Usually I would require it, but with this remote learning nonsense, that just seems cruel and unusual. So, yeah, my coffee pot. I'm gonna have to brew a second pot now. My wife got some coffee and my son did, and now I only have half a cup here. Well, this is a giant mug, so I guess it's probably a regular one. Yeah, so we'll do another final project. Hopefully it'll be interesting. So I think we can do something fun is kind of the goal, rather than just something boring. All right, so our second look at classes. So let me fire up a new project here. Java application, in the right folder. This is Chapter 8, Part 1. I don't know if I have a favorite magic. I'm not sure. I like all the, learning how to code stuff. Data structures is a lot of fun. And I think I'll be teaching that over the summer. It should be fun. Mostly we just do coding. Like there's a quick Chapter 1 you do in the previous class. Yeah, it turns out other classes for 1500 did the ice cream shop application, which just made me sad for their final project. So we did something much cooler, for sure. Much cooler. Happy Tuesday. All right, let me just make sure this runs. I'm sorry, Sweet Tea. We're reviewing that internally within the department now, so... Yep, it didn't actually run anything, so let me go change that compile on save option here. Yeah, no, we're going to build out a GUI application with buttons and boxes and text boxes and all sorts of good stuff. It should be fun. Should be fun. I mean, I'm a giant nerd, and I think some things are fun, and other people are not, and they don't think it's so fun. But, you know, it's okay. All right, let's see if make sure I get Happy Tuesday. All right, cool. There we get our message. So it builds right. Builds correctly. Now we're in good shape. So I'm going to go and add some classes here. Let's do a new Java class. And let's see. We want to... You know, we can reinvent the wheel here. It's okay. So this is math is fun. What we're going to call this one. Yeah, we use scanner for the keyboard input handling and stuff. So with math is fun, we're going to do a couple mathematical functions here. Right? And what we want to do here is we're going to look at how we can use static methods and static fields to do something with math here. So I don't need to make an instance of my math class here to work with it, because there's no instance variables. It's just some static helper methods. And the idea about static is that there is no instance, right? It belongs to the class. It's defined at the class level. So what we had done before, right? Scanner, we make a new scanner instance, and we have an instance of scanner using systemin. So we have an instance of scanner, and then we're using it using the instance we're calling keyboard. So keyboard next line gets me that one. But double.parseDouble, we didn't have to make a new double and then call that double by name. So double.parseDouble is a static method because you don't need an instance. It belongs at the class level. So typically I'll call them class level variables or class level methods. So what we can do here is we can define a public static, I think it's final, I think we can do this, final, and we'll call it pi, maybe that's approximate, because again, it's not precise, 3.14159, that's probably close enough, right? Oh, geez. No, I did it wrong. What did I do wrong here? Oh, public static, double goes somewhere in here. This is what I get for not copying out of the book, right? Nope, did it in the wrong spot. Double. I can never remember. It's not worth remembering. It's all right. This is part of the fun. Where do we put it? Okay, there we go. It goes there. We tell it it's a static final value called double, pi approximate. APP, maybe? 2 P's? 1 P? I forget. Yep. So, yeah. There's probably 2 P's. I forget. It's okay. Spelling's not important. At least not for now. So what this is now, again, we've said it's final, so we get to assign it one time and then it's never changing. And anything that's final, we typically give these uppercase names. Developing your education, yes. So we can reference this without an instance of math is fun. We just say math is fun. So I can say math is fun dot, and I get my pi approximate, not pi approximate, if we wanted. So it's a static value we have access to. Now again, I know you can get stuff out of the math package. We're trying to do our own illustration here because math is fun. Then what we can do, we can have more static methods. So public static, what do we want to call this one? A double for, how about calculate, lowercase, sorry. Calculate circumference. Wow, ference. I am terrible. Okay, I'm going to Google that one because that's embarrassing. Circumference. Yeah, was that right? Did I have it right? It looks wrong. Circumference. Circumference. Oh, no, I think I was missing an E somewhere in there. Anyway, so to calculate the circumference, given a radius. Radius. right? We can do this. Radius. Man, this is just embarrassing, my spelling here. All right, remember your formula for circumference is pi d, pi times diameter. So we're going to return my pi approximate times radius times 2. You give me a radius, I'm going to multiply by 2, multiply by pi approximate, and then return the value. Okay, that's it. So now I can come back in here and I can create a circumference. So let's just do a silly little loop here. So we're going to say, I don't know, we'll have a string for again equals y, and we'll say while again dot equals y equals ignore case, right? Thinking back to your Java 1 class, 1500, just in case my users don't type in uppercase or lowercase, right? Just ignore it. Yes, circumference. He was the Knight of the Round Table. You know which Knight of the Round Table they did not expect, though? It was never expected at a battle? It was surprise. Okay, so as long as we want to do this again, we're going to ask them. So let's make a scanner here, right? So we'll say scanner keyboard is a new scanner given system.in. Cool, we don't know what a scanner is. Let's import it. Thanks, NetBeans. So we'll ask them, right? So enter a radius. And we can have a double radius is double.parseDouble. Parse double given my keyboard.nextLine. Right, so they type something in. We try and parse it as a double. Great, we got a radius. There's a laugh emoji is crying. Yeah, it's a free dad joke. All right, so we've got a radius, and then we can print the circumference of a circle with a radius of, and then add in my radius. Okay, let's bring this down a line here, right? Is add in here, and we're going to call math is fun. Oops, math is fun. We're going to do our own one. Dot calculate circumference given the radius. So again, it's a static method. Radius. All right. So if you have typos, don't change it one at a time, right? Because that's slow. Go to refactor and rename, and it will change it everywhere. Radius. There we go. See? And it changes it everywhere. Use your tools, friends. Be lazy. I mean, efficient. Be efficient. Okay, and then we'll ask them if they want to do it again. You want to calculate another. And then I always like to, say like Y or N or something. Like, give the user something so they know what they're trying to enter. And then next line. Okay, so we'll just keep on keyboard. Man, I'm almost embarrassed. Almost embarrassed. Okay, we'll figure out if they want to do it again or not. So we're just having some fun with our file here. Okay, so enter a radius. So how about a radius of 15? Circumference is 94. You know what? I don't really trust myself here. I'm not going to go bother writing a unit test. You could and all, but I'm just going to go to Wolfram Alpha here. Wolfram Alpha. Come on. Okay, there it is. Circumference is wrong. Did I spell it wrong, you mean? Oh, yeah, that's okay. I can spell things badly here. Here. Okay, I fixed it. Circumference, a circle, a radius of 15. Let's see what Wolfram Alpha says. Wolfram Alpha is just amazing, by the way. 94.2478. And we said 94.2477. We got close. Probably that's a rounding error, right? I think that's close. What do you think? we did all right. So again, I didn't unit test it. I was feeling lazy. You can unit test static methods too. There's nothing wrong with that. Yeah, our answer is acceptable, of course. Yeah, close enough. Bing gives you free coffee. You can earn points from Bing, and then you can get a Starbucks gift card to get free coffee. Although sadly, I don't leave my house and drive past one anymore. Okay, so cool. Do we want to do it again? Sure, let's do it again. How about a radius of 10? Great. Yeah, let's calculate another one. How about a radius of negative 10? Huh. Huh. Negative 62. Feel like that's wrong. But that's okay. Just math, right? We're just pretending here. All right. Radius of 2 million. You just have to create a Microsoft account and then let Bing track you. You're selling your data to them, but I mean, Google takes your data anyway. You don't really get anything free out of Google. I mean, you get their service for free, but I mean, Microsoft basically pays you to use their search. So, no, radius squared is for area, isn't it? Circumference is just pi d, if I remember my math right. Cool. So, that's a static method. This is a static attribute. Now, you can also have static attributes that are changeable here. So just for fun, and this is totally nonsense, but you can, public static int math counter is 0. And every time we calculate circumference, I'm going to take math counter, and I'm going to add 1 to it. I will just do plus plus, right? How many times have we used math? Yeah, pi r squared. Oh, no. Yeah, pi times radius times 2 is circumference. Pi r squared is area. I'm not a math teacher. I apologize. But, you know, I think we're close. Why don't eggs tell jokes? They crack each other up. Wisp the third. I love it. All right, so this is a static field, a static attribute. So it belongs at the class level. And then when we're all done, right, we can print out here, you used our amazing math function, plus math is fun, dot math counter, times. Let's cut that down a line here, sorry. So it's accessible at the class level. So we use the class name for it, dot something, dot that value. It's math you haven't used since 8th grade. So that should count every time I do my radius function. It will add 1. Again, this is just a contrived example, but you can do other fun stuff with this. So 10, do it again, 15, and we'll be done. And we used it 2 times. So you can have attributes at the class level here. You're a faux pas. If you tell a dad joke and you're not a dad. And you guys are on fire today. So double dot parse double here was converting a string to a double. So like I could use my keyboard next line here. Because keyboard, the scanner, you can do like next double. But remember, if you're mixing next double and next line, you have that trailing white space. Because next double doesn't get the enter key, which is like that \n. So you'd have to do a next line anyway to clear it off the input. So I always recommend just parsing and using strings. It'll work better for you. Yes, yeah, the first error you run into in Java 1, for sure. Okay, let's see. What else do we have here? Instance and static. Yep. I like that. Okay. I think we're in good shape there. All right, so the next piece we're going to do here, we're going to write another class for fun here. And let's call this one, let's see, let's do a, rectangles are boring, but they're okay. There's a hard drive. Oh my. Programmer jokes, awesome. All right, so why not? Let's do the bank account class because that's fun. We're going to write a class for bank account. So again, when we're designing classes here, we need to think about what sort of data do these things have. So we probably have a double for balance. Right, your bank account probably knows your balance. It probably has your name, right? Is that like the owner name or something? Owner name, and then maybe a type or something. I don't know. What else would be? That's probably enough for now, right? We'll have your name and your balance and your bank account. And then we'll make a constructor, bank account. Remember, the constructor has the same name as the class, and there's no return type. And this will probably take a string for the owner name. Owner name. So I'll take my instance of owner name. So this dot owner name is the owner name argument. Okay, this dot is this instance here. Ooh, an account number. There we go. Private. That's probably also a thing, right? Account number. Probably a string. I don't know. Is it? I feel like integer is probably the wrong value there. Right? Maybe we can make it an int. Sure, why not? We'll screw it. We'll just be silly here. Okay, so we'll set the owner name. We'll set the balance to 0. Then let's do this silly thing here. Let's use a static field, but I don't want to make it public. I'm going to make a private static value here for current account number. And we'll start this off at 1. Private static int. Thank you. The type that you are, int. And we don't want to make it final because we want this to change. So I'm going to take the account number and we'll set it to the current account number. I'm going to take my current account number plus plus. You could do that all in one line. I don't know. I always feel awkward about putting a plus plus in an assignment operator, but you could just put the plus plus here because remember the postfix post increment will use the value and then increment it. So either way is okay, but I think this might be more clear here. So this way, every time I make a new bank account, I'll increase the account number. I'll use 1 and then I'll increase it. And I'll be 2 and I'll use that and I'll increase it. And I'll use that and I'll increase it. And I'll use that and I'll increase it. So private here. So we're saying these values, if they're private, we only have access to them inside a bank account. So we need to add some gets. So I'm going to go insert code. Actually, no, I'm going to be smarter here. I'm going to come down below before I insert code. Then I can insert my gets. And I don't have to copy paste anything. So we want to get account number. We want to get balance. We want to get owner name. We don't want to get current account number. That's our static field, right? We don't need to give access to that one. So you can get your balance. You can get your owner's name. You can get your account number back out. Okay. Then we're going to add some methods. How do we interact with bank account? Well, we should be able to deposit money. We should be able to withdraw money. Okay, so we'll have a public, and again, I'm going to use a Boolean for if this was successful or not for deposit. And this will be a double money to deposit. Okay, and then we'll have a Boolean withdraw given a double money to withdraw. Aha, and I'm remembering now. Someone asked me, because I'm dumb, and I forgot, that I wanted to tell you about test-driven development. And we didn't get to that last week because my internet was crappy. Thank you, Comcast. Yeah, I mean, in real life, account numbers are a certain length and they mean certain things. We're just pretending here, right? We're not making a real bank account. So it's fine to be 1, 2, 3, 4, 5, 6. In real life, yeah, they have different accounts and their routing numbers and all sorts of things. Okay, so but for test-driven development, I know what deposit is supposed to do. I know what withdraw is supposed to do. So all I'm going to do here is just say return false. Return false. This is a stub. So I have a method. It doesn't do what it's supposed to do yet. Okay, so this is to do write me or something like that. But we need to have a method here so that I can write a test. So I'm going to write the shell of my class. So here's all the methods I'm going to have. I'm going to have deposit, I'm going to have withdraw, the gets, sure. I mean, those are automatic. I guess I wrote a constructor, so maybe I should have written all of this, but that's okay. I mean, these are the ones we really care about. We want to test deposit and withdraw. So I've designed my class. Right? I know what it's supposed to do. I know how it's supposed to act. I haven't actually written the code yet. So for deposit, right, we can't deposit negative. Other than that, sure, the bank will take your money, right? For withdraw, you can't withdraw a negative number because then you'd be adding money. You screwed something up if you're trying to withdraw a negative. And you can't go below zero. Right? You can't take out more money from the bank than you have. Although banks are happy to let you do that and charge you all sorts of fees nowadays. But again, let's not get into how they prey on poor people. Banks are just, they're really sad how they make their money nowadays. So anyway, so I have a method. It doesn't do it yet. But now what I can go do is I can go write some tests. So I'm going to go to navigate, go to test. I'll say I don't have it. So remember, when you're writing unit tests, make sure you pick JUnit 4. The other JUnit, the latest and greatest version, doesn't work for some reason. And I haven't been able to spend enough time to figure it out why. I spent like half an hour trying to search it online and didn't get anywhere. And someone said just use JUnit 4 because it works. So I was really happy with that. So JUnit 4, the method's great here. Everything else is probably fine. We don't need these default method bodies. I think that's probably harder than, because it just gives you more junk in there that we don't really need. More dad jokes. You got it. You got it. All right, let's see. What day do chickens hate the most? Posture check. Yeah, thank you. I got my back thing here. What day do chickens hate the most? Friday. It's so bad, it's almost funny. All right, so I'm going to generate the tests here. Again, get rid of some of this stuff. That's fine. So it doesn't give me any tests, right? Because I unchecked that. That's okay. No big deal. So I need to write my own. So you do @test and then public void, and we're going to test withdraw. Withdraw. Okay, and we're going to do this AAA format. So we're going to arrange, then we'll act, then we'll assert. Why did the programmer quit his job? Because he didn't get a raise. Okay, so to arrange, we need to figure out how much we're going to withdraw. So we're going to have a double for expected balance, right? Our expected balance, we'll say, is going to be like $10. Okay, and then when we're withdraw is actually kind of hard. We have to add has to work first, but that's okay. So then we'll make a bank account. Account equals a new bank account. And we don't care about the owner's name, so I'm just going to do an empty string. No big deal. And then I need to add some money first, or deposit some money. So if we deposit, I don't know, let's put in $20. Then I can go take this back out. So I'm putting this up in the arrange section because it's not the part I'm testing. Again, it's going to fail, and that's okay, because we haven't written deposit yet, but we'll get there. So then in act now, we'll have a Boolean for the withdraw result is my account dot withdraw, and let's try and withdraw $10. So if we put 20 in and we take 10 out, we should be left with 10. And then we'll have a double for actual balance is my account dot get balance. So I need all these methods here, right? I need to have the withdraw method. I need to have the get balance method, despite me not having any code for withdraw. And then I can assert. So I'm going to assert false. Or no, I'm sorry, assert true that my withdrawal worked. So my withdrawal result should be true. Because if I had $20, I should be able to take 10 back out. Hydration. Enjoy your coffee, folks. And then my balance now I'm going to check, is my expected equal to the actual? So I'll assert equal my expected balance and my actual balance. And are they within, 0.00001 of whatever? Right, some delta, because these are doubles, so you need to have that delta. Okay, now what happens when I run my test? It's not going to pass. It should fail, which is good. That's the point of test-driven development, is you want a failing test to start. And it sounds a little funny, but I promise it's a really good process. Assert failed. There's my test explorer. There we go. Boop, 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 boop. Where'd it go? Yeah. Okay, so it failed. Okay, I should have gotten a red. I don't know. That's all right. We got yellow. Close enough. Close enough to failure. Yeah, it failed. So it's not working, which is good. So I wrote a test. I don't have the code to make it work yet. So what we do is we know what the code is supposed to do. So we're going to write tests for all of that behavior. So we're going to try withdraw over balance. If you try and withdraw more money than you have, so if we don't deposit any money, and I try and withdraw 10, I should get back a false, assert false, and then my actual balance should be 0. Right? So if I make a new account, I don't put any money in it, and I try and withdraw 10, it should tell me, no, you can't do that, and then my balance should still be 0. So now this test should also fail. That one failed. Yay! Uh-oh. Passed. Oh dear. Oh, it did pass. So we were by default returning false here without any code. And if we don't ever put any money in, our balance is 0. So get balance actually works. So that's a little bit unfortunate. Ideally with test-driven development, you want the test to fail first. And one of the reasons you want it to fail is that it's possible to screw things up, and you're not actually testing anything when you write your tests, especially with complex code, right? So just be careful with that. I mean, in this case, I'm okay with it because I know we put in false here. We had no other way of doing it, and that our balance was 0. But the idea is I have a test now that makes sure that the correct behavior happens. You know what? Let's change it. Let's change it here. Let's deposit some money. That would actually still pass. Oh no, it wouldn't. It wouldn't. So if we add some money here, and I try and withdraw more money than that, call account.deposit. Let's deposit my expected balance. There we go. So now the test will fail. I'm going to feel a little bit better about this. So if I deposit 10 and I try and take out 20, I'll still have $10 left. There we go. All right, now it failed. Okay, so we expected to get $10, but we actually got back 0 because deposit doesn't work yet. Oh, sorry, got some in my eye here. Okay, so we tested deposit, and we're testing both cases where withdrawal works and we withdraw too much. Okay, we're going to do the same thing with deposit now. So we're going to write a test, void test deposit. Ooh, and actually we want to do one more test here. So just going to copy paste the whole thing here. This is withdraw negative. So if we try and withdraw a negative number, it should be false, right? And nothing should happen. So our balance shouldn't change. I've got 3 tests for withdraw to make sure I'm getting each case here. Oops, I changed the wrong one. What did I do here? Oh, let's withdraw negative. Let's withdraw. Oh, I gave them the same name. This is withdraw. What did I do? I changed the wrong one. Withdraw over balance. But I screwed that up somehow. That's all right. So if we try and deposit 10, and we actually withdraw 20, we should get false. Cert false. I think I copied the wrong thing. That's the problem with copy pasting things. Why can't programmers change the light bulb? Why can't programmers change the light bulb? Look at that. Someone else is doing the dad joke for me. All right. So I don't know if you guys, I think everyone has to take a science class, right, for your degree program. I forget, like a general science. So when I took my chemistry course, one of the first things we had to do in lab, and this was just a fun, silly lab, is we had to make a glue. So we had to formulate our own glue given some materials. And then it had to be strong enough to stick this, it was just like a 2x4 to the wall here. So everyone was trying to do their project and get it sticking to the wall, and some people's would fall off and whatever. And the teacher came around, and the prof came around, and couldn't pull mine off the wall. Just it stuck amazingly. It was great, and he couldn't get it off the wall. He was impressed. So I ended up doing the best in the class on this make your own glue project. I totally nailed it. Okay, so I've got some tests. Right, and then we're going to do the same thing for deposits, the two cases, right? Don't deposit negative, and other than that, it should work. Deposit negative. All right, so we'll just copy paste some of this stuff. So if I deposit my $10, I should get $10 back out. Actually, that's going to go in the ACT section here now. And, oh, that should be the result. So this is the Boolean deposit result. Should be true, right? It should work. So if I add $10, I should have a balance of $10, and we're good. And then if we try and do this with a negative value here, I should get back false. Insert false. If I give it a negative value, like negative 10, and we should get $0 back out. So this one, it might actually work, again, because deposit should just return false every time. Okay, so one passes. Again, I'm going to feel a little bit bad about it, but it's okay. Yeah, thanks for dropping by, Magic Gnome. Take care. All right. So we've got a couple tests here now. So this is the test-driven development. I wrote some tests because I know what should happen in my class, but all I have is a method stub. Right? I don't have any working code here. Now what my job is, because I've said, here's what the class is supposed to do. I've designed it. I know how it behaves. I even wrote tests to ensure that that expected behavior happens. Now my job is to make these tests pass. So it makes me make sure that I'm focused on the task of, okay, now all I need to do is make it work. And sometimes that can help, because I don't know if you guys ever like are having fun with projects or getting involved in like, you like, hey, maybe I can make this a little bit more interesting, or I can add this feature, or I can do this other thing. It helps cut down on that with test-driven development, because all we're doing is making sure the tests pass. And there's something actually very like satisfying about making failures turn to green check marks. It's just a fun feeling. All right, one more dad joke. And okay, here we go. So it's probably a really old movie now, but if you guys have ever seen Back to the Future, I saw that as a kid, and I always wanted to get a DeLorean because I thought it was like the coolest car. But I was thinking about it, and you know, if I got it, I don't think I'd actually use it very much because I'd only really drive it time to time. Okay, so we're going to make our code work here. So we're going to make deposit work. So first, if money to deposit is less than 0, we return false. Boom, done. Now, again, the else here is redundant, because if you hit a return, code's done. So I'm going to take my balance, and I'll just plus equals the money to deposit. That'll return true. Oh, I'm sorry, Mindful. Your stream froze right at the great joke. So we're just making deposit work. So if you give me a negative value, Nope, false, nothing happens. Otherwise, sure, we'll take the money and then we'll return as true. Then I come back to my tests and I can run them. Let's see, it's one of these buttons, rerun. And we'll see which ones work. Yeah, today is Tuesday. This class is Tuesday, Thursday. I think that's also in my Twitch info. So now, some of the withdrawal ones worked because now we're depositing money. Don't feel too bad about that. It's okay. We'll come back. Now we're going to do withdraw. So again, first we're going to check if money to withdraw is less than 0 or money to withdraw is greater than my balance. Look at that. We can use some logical operators here. If you try and withdraw negative or you try and withdraw more than you have, return false. Otherwise, take my balance, subtract the money to withdraw, and return it true. It worked. Okay, and then we'll run some more tests and see if our tests pass. I'm sorry, Mindful. Hopefully you can catch it on the VOD. Okay, we're doing okay so far. Now the other thing we haven't checked yet is this account number and the owner name, like getting the balance. So we've gotten balance a couple times. We haven't got owner's name. We haven't got the account number out. So let's try that. Let's add another test. So test. This is void. I don't know. Test constructor. Sure. Why not? So because our constructor is setting the owner name, I'm going to use the constructor to test that. So we're going to have the arrange. We're going to have a string for expected owner name is Eric, and an int for expected account number equals, let's do 2 here. Okay, and then I'll make a bank account, dummy account, oh, we'll just call it account, equals a new bank account. And the first one here, we'll just do nothing, and I'll do it again. That's probably be in the range here now. So this is act. We're going to call that code. We'll make a bank account. So this first bank account should get account number 1. I'm going to do it a second time now. So account equals a new bank account given my expected owner name. So again, I'm just doing this because I want to get that first number out of there to get the second number to check to see if it works. I'll have an int for actual account number is my account.get account number, and then a string for actual owner name. Owner name is my account.get owner name. Okay, and then we can assert. So we'll assert equals. There we go. That one. My expected owner name, or expected account number. Sure, an actual account number. And then we'll also assert equals my expected owner name and the actual owner name. Actual owner name. Okay, so I'm just calling this constructor once just to make sure we're going to get the next account number, to make sure that part is working here. So I guess that's constructor and account number. Sure, why not? We'll make sure it does both. All right, let's run that test. So I should get account number 2, and it should be owned by Eric. Just thinking hard about it. Why did the sun skip college? It already had 1,000 degrees. Nice. Uh-oh. We got an error. The test constructor and account number should be public. Oops. Public void. There we go. I screwed up the name of the method there. So public void test constructor. One more time. That's part of the, I guess, of doing it, writing my own here is sad, instead of letting him auto-generate, but that's okay. All right. Uh-oh. Constructor. Expected 2, but it was 7. Ooh. Oh, dear. So the tests here are running in a particular order, and because that's a static field, that was the 7th time we called the bank account constructor. That's unfortunate. That's a bummer. Okay, let's just take that one out. Then Bank account. Let's see if we get a 6. Bank account. So I just took out the extra call because I didn't need it. So they all run in a row here. That's kind of yeah. I'm sad about that. Static fields are ugly. All right, so it worked. 6 tests. We got account number 6. I don't know why that one's the 6th one to run because it's at the top, but that's okay. I feel like this is probably pretty fragile, and this was unfortunate, but that's okay. We tested the code. This was just an example here. All right, so we've covered static attributes and static methods. We did some more practice with testing. We talked about project 1. Don't forget there is study group today at 4 o'clock, right? I think it's 4 o'clock. I always have to double check because I forget things very easily. I will go commit my code to GitHub here. Let's see. Let me open up my GitHub client. Should see a bunch of new stuff. Where's my GitHub client? Maybe. Maybe. There it goes. Nope, nope, wrong one. Wrong one. GitHub client. There we go. Okay. 2151, enter. Oh, sorry, I put it on the other screen here. There we go. Okay, so here's some. Do we change vehicle? We must have. Sure, that's fine. So this is chapter 8, part 1. Commit and push. So notice it gives you this line level differences, which is amazing. So red is removed, green is added. Git is fantastic. Okay, yep. Today at 4 o'clock. Wednesday, that's tomorrow at 6 p.m. And then Thursday we have class again and study group at 4 p.m. So if you attend one of those for a decent amount of time, again, if you can't make the entire hour, that's okay, but like more than 5 minutes of dropping in, ideally you're there for a quarter of an hour, half an hour or something to make it worthwhile. Drop by that Zoom meeting, get to know each other, and our fantastic SI Tim can help you out and go over some of these topics again. It's in the calendar event here. That's his Zoom meeting, so I didn't want to put that public on Twitch. Yeah, you can find it in D2L. It's there, or it's also in the content section. There's a document in it. Yep. Yeah, we'll keep that one private here, just in D2L. Okay. All right, you guys got anything else? Other questions, thoughts, concerns? Glad the internet was stabler today. Stabler, is that a word? Stabler? More stable today? And then I'll see you guys Thursday. All right, just one more pausing for questions here before I end the stream. Yep, yeah, we can chat if you're having trouble with NetBeans for sure. Just send me a message there, sweet tea. All right, you guys take care.